So now that we have a notion of center and a notion of spread, you may be wondering if we might have a way to connect the two concepts, mean and standard deviation, just as we did with sample data, to determine whether we have values that are considered extreme by our standard of measuring how close an outcome is to our mean of all possible outcomes. So to clarify, what we're talking about then is the strong range rule of thumb, but now for random variables. The idea being, let's suppose we have some random variable x that we're representing using a graph, possibly, and all we know is that we can reasonably say that the distribution graph is roughly bell curve shaped. And we'll have a way to make that more precise in the next chapter. In fact, that's the main theme of the next chapter. But for now, just know that we want to be able to fit a bell curve roughly, maybe not exactly. And then we'll know that this range rule of thumb will apply. So our key players here are mu, the expected value, and sigma, the standard deviation of this variable. Then, for any outcome x, we say that if this outcome is less than mu minus 2 sigma, in other words, more than 2 standard deviations less than the mean, then we would call this outcome significantly low. And, or more accurately, or if it's greater than 2 standard deviations above the mean, then we call that significantly high. In either case, we would call x a significant value for our distribution, and x is an outcome, right? So it's possible that we have some outcome represented, for instance, maybe out here, that is then significantly high for this distribution. So why don't we gain some intuition here using the dice roll, the sum of the two dice roll variables. So we'll choose this distribution where we found previously that the mean was 7, and you'll have to take my word for this, but you could also follow this calculation in the previous video where we had the probability distribution table. You could use that information to find the standard deviation, but this is the standard deviation that we found. All right, so what does this apply to? So anything in the support, so remember that the support is all the possible outcomes. That's 2, 3, 4, and so on. Our mean is somewhere in here. So there's 7. And it's possible that one or more of these values is far enough away from the mean in terms of multiples of the standard deviation that they are considered significantly low or significantly high. So to find these bounds, let's calculate mu minus 2 sigma and mu plus 2 sigma. So these are like the fences or the boundary for the range of usual values. So there are some that are going to be within two standard deviations of the mean, and some that are going to be outside of that boundary. So we find that mu minus 2 sigma is going to be 7 minus 2 times 2.414, and that is 2.172. And the upper boundary on this will be 7 plus 2 times 2.414, which is 11.828. So in context, what this means then for our support is that anything, and we can squeeze in where these boundaries are in between 2 and 3 and between 11 and 12, which means then that all the values between those two boundaries are within 2 standard deviations of the mean, and so they're considered usual. But 2 and 12 are correspondingly lower than and higher than 2 standard deviations away from the mean. So our significant values here are x equals 2 and x equals 12 are significant. And it is standard then that, according to these calculations, that these values are going to be most likely to be in the tails of the distributions, so the far left and the far right. And what the strong range rule of thumb is really giving us is a heuristic for knowing what we should be alerted to if we are taking random values from this distribution. So we should be concerned if 2 and 12 come up repeatedly, because that would be suggesting that we're not taking representative samples from this distribution.